This is Kevin, and I'm a software engineer at Google and a graduate from the EECS program at UC Berkeley. Go Bears. And today, I'm going to be talking about LeetCode number 6, ZigZag Conversion. This is a medium difficulty question. All right, so for this one, basically what the question is asking is you get some string here. PayPal is hiring is the example. And you get a number of rows, and you actually type in your string going downwards that number of rows. So let's say it's 3 rows. So let's say it's PayPal is hiring and 3 rows. Then you go down 3, right? Then you come back up. PayPal. So you go down 3, then up 3, then down 3, and kind of zigzag your way, right? PayPal, like this, and so on. And then once you have written this kind of zigzag type of thing, you go across the rows. So let's say it's like this. It would be PAHN, APLSIIG, YIR, right? From here, and then you just add these all together, copy those together, and then put that into one long string. It kind of rearranges the letters and output this, and it's dependent on some input string and the number of rows. Cool. So you probably understand that. That's pretty straightforward. So I think with this question, the challenge of this is it's not really that hard conceptually. It's more if you were to do this, on a piece of paper, it's pretty easy to kind of rearrange, follow this pattern and rearrange. So it's the concept itself is not too bad. But I think what this problem is more testing is, whether or not you'd come up with an efficient way to kind of rearrange all this stuff in code, and also to do it in a way that is, time complexity, space complexity efficient. Discuss, why you're doing it in a certain way. So, cool. In the solutions, they actually give 2 approaches: sort by row, visit by row, and actually, they're pretty. This problem doesn't really have too much room for flexibility, and I think these are actually pretty good solutions. So I'm actually just going to cover these and explain how they're done. So the first one, the first approach basically, you can basically what you can do is, as you visit each character, as you iterate through the string, you basically can just keep a number of buckets, right? A number of in Python, it's going to be at a Python list. And just keep appending each letter and visit. So once you visit, as you visit in order, right? You go here, P, A, Y, and then go back up and you put in a, what is next? P, then you go back up and you put in an A, and then an L, and just kind of go in order as you visit these lists. And then the list will get filled up, and you append everything together and make a string. So that's basically that approach. So let's go ahead and try that. This one, let's see. I'll go ahead and code that up for you, and we can see how that would look. Cool. All right. So first, we're going to have, let's see, let's keep an index so we know which row we're on. So this is going to be row 0, 1, 2, right? And we're going to also have to keep our resulting list, which is going to be a list containing each of these lists. And so we can actually initialize this right now. Okay, so that's going to be for rows. This is just kind of like the way Python allows you to initialize a list with an empty list for each one in num rows. So let's say num rows was 3, we'll get 3, it's going to be 3 empty lists. Cool. And then we can just go ahead and iterate through our So it's like this. For C and S, right? This is our input string. For each character in our input string, we'll take res and the row, right? We have one, we'll have one bucket. So let's say, again, we'll use an example of 3. One bucket we'll have 3 buckets, and we'll have one bucket, we'll look at the first bucket, which is at index 0, right? And we're going to append our character to that. And now we need to increment our row. So after this, it's going to be row will go down and then back up. But so first let's go row plus equal 1. But once we get to the bottom, we actually have to go back up the other direction, right? So it's actually not, so this is where it gets a little bit interesting. So when would we change directions? Basically, when the row is at the top or at the bottom, we need to start moving instead of going +1, +1 and incrementing it, we need to go -1. So we'll just keep flip-flopping like that. So when we get to the end, so basically we just check, right, it's the 0 index or the last index. So if row equals 0 or row equals num rows -1. So in our example here, we have 3, num rows is 3, so our final index is 2, so it's 3 minus 1, right? So row equals num rows -1. And then we will flip our direction. So we should maybe keep a variable to kind of say our direction. So let's call that delta and initialize to something. Let's just call it, okay, let's just say it's 1 actually. And so when we get to each of these, we'll flip it around. Delta times equals -1. So when we get to the ends, this will become, it'll be 1, 1, 1, then -1, -1. When we get to 1, 1, 1, -1, -1, like that. So that's how it's going to work. And then we would have it add delta. So delta will keep flipping signs at the end. And since we're actually starting on row 0, it's going to do this flip right in the beginning. So we actually can just initialize this to -1, so it flips to 1 when you start. Cool. And then I think that's, let's see here. I think that's basically it. So then we do it this way. We're going to fill up our result. Now we just need to, so let's just mark some of this stuff off. Iterate through our string. Consolidate result. So we just have like a bunch of lists now with characters in the list. So we'll have to just consolidate that. So for in xrange len result res at index equals I'm just going to go ahead and join each one. So I'm just going to each one is basically right now is actually going to look like something like this, right? It's going to be p comma a comma whatever. It's going to be a bunch of 1 character. So we're just joining them into a string, and then we'll return. We'll take the final one and kind of join that up together as well and return that. Cool. So I think this is, this basically does what we described up here. But one thing is also we want to make sure, does this work for all use cases? So, I mean, some of the corner cases, the one corner case I'm thinking of is, what if num rows is 1? What happens? So if num rows is 1, then you basically have one of these arrays, and then you have your delta, and it will keep flipping, and it'll keep adding, and you'll move away from your row 0, but you actually want to stay at row 0 the whole time. So this is kind of hard to capture in our iteration, so we can actually just, but we know if the num rows is 1, we actually just return the original string because we're not actually doing any transformation. So that's probably an easy way to kind of just get out of that, right? Num rows equals 1, return the string. The other end of the corner case is, what if num rows is something really long and greater than the number of characters in the string? And that, in that case, you just be going downwards, right? You would just be kind of going like this, pay, whoops. And you just, everything would just go in a vertical line. And that's also, it's just going to return the same string as well. So You could potentially add it up here, or num rows is greater or equal to length string. And you would just return s. This one isn't necessarily required because if you were to iterate through this, it would actually, it would just put each thing into the correct bucket and it would still be fine. But it does save us in the case if we have a small string, like let's say it's pay, and then we had 10 for the num rows, it would actually create 10 of these guys, right? And then only fill up 3 of them. So I guess if we add this case in here, it actually saves us a little bit of space that we don't need to make a bunch of empty lists. So you could talk about that if you were in an interview in this kind of corner case. Cool, so that kind of covers it. I think those are kind of like the main odd use cases. And I think that should be it. So why don't we go ahead and try running this and make sure that it works. Oh, string list found. I meant to join the specific element, not the entire result. All right, cool. Works for this case. We talked through some of the corner cases, so I'm going to go ahead and submit this. Cool. So this one works for that first approach. Awesome. All right. So what is the time and space complexity of this? So for time complexity, we essentially are iterating through each character in the string, and we're not doing any other operation that, and we're also creating this our kind of two-dimensional array based on the number of num rows. So I think those are the two things that are dependent on the size. So we can say like it's going to be time is going to be big O of n, where n is the number of characters in string, plus k, where k is the number of rows. But k should always be smaller than n because we have this, right? If we keep this in here, whenever k is bigger than the length of whenever the number of rows is bigger than the length of the string, we just return the string itself. So we don't actually have to create all that. So this would always, so n plus k is always going to be less than n plus n, right? Which is equal to 2n. And if it's 2n, it's just n because we dropped the constant. So this is going to be big O of n. Space. We have to maintain one array for each row, but that's not actually our limiting factor. It's actually a number of elements inside of that. And that, again, it's going to be dependent on n, the number of characters in the string, because the number of rows is actually less than that, so that becomes the dominant term. So it's time and space, O of n, O of n. And of course, yeah, we'll leave it at that. Cool. And then, okay, so this is the first approach, basically kind of just doing it literally how you see it, like kind of zigzagging your way and assembling that. Let's go move on to the next approach. There's another way of doing this. So, what would that be? Second approach is noticing, let's go back to the description. Get this guy, PayPal is hiring. The second approach is noticing that there's actually a pattern in the order that you access these characters, right? You would first look at the first character, and then you go 1, 2, 3, 4, 5, 6, 7th character, 8, 9, 10, 11, 12, 13th character. So for the first row, 1, first character, 7th character, 13th character. Or 1 plus 6 plus 6, right? There's sort of a pattern here. Row 2, what is row 2? You're looking at the second character. Actually, let's do it this way. Let's go by indexes, so, I hate when it does that. Let's go by indexes, so it's easier to keep track of. All right, so it's 0, plus 6, plus 6, right? And for this one, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 13. And what is this? So it's going to be 1, plus 5, plus, yeah, it is, right? I think I missed one. 1, 2, 3, 4, 5. Oh, this is actually a 5. Okay. 1 plus 4 plus 2 plus 4 plus 2. Oh, interesting. A pattern is starting to emerge. Row 2. 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's it. So that's 2 plus 2 plus 4 plus 2 plus 4. Okay, I'm starting to see a pattern here. I'll just complete this for the sake of completing it. So it's going to be 3, and then plus 6, 9, plus 0, last one, no. So it's just going to be 3 plus 6 plus 6. So we really do see a recurring theme here, right? There's basically a cycle is 6 characters, right? It's 1, 2, 3, 4, 5, 6 from here to here. And then we have another cycle, and then we have another cycle. And in each cycle, the first and last rows, they just they're in the cycle once every 6 times, and the rows in between, they're in the cycle twice. So it's basically your starting point, and then there's another point within the cycle that you would get to. So I think the first thing to think about is, what is our cycle size? So this is with num rows equals 4. With 4, our cycle size is 6. What if we had 3 for our num rows? Then it would look like this. Actually, I think, okay, well, let's also finish it. Right, like that. So 1, 2, 3, 4, and then it'll repeat again and repeat again. So with 3, it's 4. What if it was 2? With 2, it would look like this: P, A, Y, P. So it's really just up, down, up, down, up, down, down. So the cycle is just 2 in that case. So the pattern emerges, right? It's basically just 2 for each one. If it's 1, it's just the original string, so there really is no cycle. It's just you just sit cycling through. So that's kind of out of it, and we would think that this is a special case. So let's kind of ignore that for now. Basically, you can get the cycle size. It's just going to be 2 times num rows minus 2, right? So 2 times 2 is 4 minus 2. 3 times 2 is 6 minus 2 is 4, right? So that's how you get the cycle is this. So let's copy this guy over here. All right. And then how do we get this other pattern here? This one's a little bit harder to, how do I explain this part? So the first element, all right, when you get to this point, it's again, right, you have this one, and this is like, you have 2 times in the cycle, and then the first time, and then this is the second part in the same cycle, and then this starts the cycle again. And this one is 6 after this one. It's just 1 cycle's worth after. So to go from this one back to this one, you basically have this one go a cycle and then minus 2 from here. Or minus, if it's this one, how do we get to this one? If you go up forward one cycle, then you go back 1, 2, 3, 4. And so that's basically all it is. It's just go forward by one cycle and then go back by 2 times the row that you're in. And that's basically the pattern. So why don't we just go ahead and try coding this up. All right. So we already said that if the number of rows is 1, we have a special case, so we just return that, so we don't have to worry about it. We know that our cycle is 2 times the number of rows, minus 2. Let's make sure to return a resulting array. All right. Cool. So now we do the iteration, and essentially what we would do is we're going to assemble this string in order. We want to get all of the ones in the first row, then the second row, then the third row, then the fourth row, in that order, right? So we'll iterate through the number of rows. So x range, non-rows, right? Where I is your row index. And then once you're inside the row, you're going to iterate through your cycles. So starting at I, then ending at your length of the string, not inclusive, and you're going to increment j by your cycle each time. Then you just say res that append s at j. And so what this is doing is, you first iterate through, your cycle length is 6, you start here, and then plus 6 to get I think it's this s, is that right? It's the I, right? Plus 6 again to get to the n, and you add that to your, and that's what this will do, and add that in there. And that kind of works for our first and last case, right? But now we also need to get our middle case, which has this second. In each cycle, there's 2 instances. So we're only capturing the first instance with this. So let's go ahead and track that. If we're in, if I does not equal 0, so we're not in the top row, and if we're not, and if I is not equal to numRows minus 1, which is your final. So if numRows is 4, your final index would be 3. So minus that 1 right there, right? If you're not in your first or last row, you actually need to get that second element. And also, so what is that second element? So like we said, it's, let's call it k. It's going to be equal to whatever your j value is. You add your cycle, right? So from here, you plus your cycle to get to here, and then you minus 2 times the row. So minus 2 times your row, right? So go forward by 1 cycle, minus 2. Or from the y, you go forward by 1 cycle, minus 4. 1, 2, 3, 4. All right, so that's your index of your final, of your second item in that same cycle. So it's k. And just make sure that k is not off the end of the string. And if that's true, then append s of k. And so now you've basically appended everything into your result, so we'll return that joined by empty string. Cool. So this one, a little bit harder to understand. It's a little bit more mathematical. It's kind of like about finding the patterns in here. But we don't have any external data structure. So let's go ahead and just make sure this works. All right, cool. Looks like it's working. Great. So this one works fine. This one, so what is the space and time complexity? So time, this one's a little bit nicer. We go through the number of rows, and then we go through the number of each of the characters, but total number of iterations. This kind of, there's 2 for loops, so you might be tempted to say it's the number of rows times the number of characters, but actually we only do this operation one time for each character. We're just visiting it in a different order. So the time is actually big O of n, where n is the number of characters in the string. And space complexity, that's big O of. For this one, we actually don't have any external data structure, right? We don't have that whole extra, array situation that we had. Where did I put it? Yeah, we don't have this whole like array of arrays, 2D array type of thing. We're just storing everything into our resulting res. So this is, there's no weird complicated stuff. It's just n. You have one letter for each final output letter. And since if you didn't, this actually ends up being your output. So if you didn't even have this, it could even say argue constant time. But we have to kind of store it, our output, so we'll just say it's n. This one's a little simpler in terms of the analysis there. So that's basically it for this solution. So these are the two approaches you can use. They actually are both the same space and time complexity, I believe. Yeah, both linear, time, and space. And yeah, that's how I would solve these. If there's any part of this video, any concepts that you feel like you need me to evaluate or to explain more, please feel free to leave me some comments, questions. I'm happy to address them in a follow-up video. Or if there's any specific LeetCode questions that you want me to cover next, then again, don't hesitate to send me a message about it. Leave me a comment. All right, other than that, that's it for this question. Good luck in interviews.